Okay, hi guys. So in this lecture, we'll be starting on mean free path, which is lambda also, or represented as lambda rather. So this is the average distance traveled by gas molecules between two successive collisions. Average distance traveled by a gas molecule between two successive collisions. Okay, so lambda can be written as U average divided by Z1. Okay, obviously Z1 is the total number of collisions taking place by a single gas molecule when it is roaming around in the vessel, and all the other gas particles were considered at rest. This was the case 1, and the case 2 we considered that two of the gas molecules were moving, so hence we took the relative velocity or relative U average of the two, and then we considered that all the gas molecules were moving. So in this case, we are defining mean free path with the thing that all the gas molecules are moving, but at a single point of time. At the time of collisions, both are moving, but and the total number of collisions by a single gas molecule would be Z1. Okay, so it was moving with average speed U average. Okay, and total distance traveled would be just U average divided by Z1. So just keep this in mind. Okay, so this would be nothing but U average divided by root 2 pi sigma square U average into n star. So getting cancelled, this implies that mean free path can be written as 1 upon root 2 pi sigma square n star. Okay, now we know that PV equals to nRT. Okay, and n can be written as number of molecules of gas divided by Avogadro number RT. Okay, and we know that n star is equals to number of molecules per unit volume of the colliding particles. So we can write rather V as, or we can also write P n upon V as from here we can write P n A divided by RT equals to n upon V. Okay, so just equating these two equations, so n upon V would be equals to P times n divided by RT. Okay, and from just substituting the n by V value in n star, so n star would be equals to nothing but P into Na by RT. Okay, and R upon Na is Boltzmann constant, we actually saw it, so this implies n star would be P upon KT. Okay, so as we saw that mean free path here can be written as 1 upon root 2 pi sigma square times n star. So was inversely proportional to Na star or n star simply. So from here we can write that as n star is proportional to p by t, lambda would be proportional to t by p. Okay, and we can write from this that at constant temperature lambda would be proportional to 1 upon p, and at constant pressure lambda would be proportional to T. And what about at constant volume? At constant volume, we can say that P is directly proportional to T. This implies lambda would be constant. Okay. So from the same we can write that as Z1 is equals to root 2 pi lambda square n square rather n star into U average, which is the number of collision by one gas molecule. Z1 is just writing here that number of collisions by one gas molecule. Okay, so this should be root 2, rather it is, we can directly in abstracted terms we can write Z1 is proportional to U average times n star, and U average is proportional to U average we saw that it would be root of 8 RT upon pi m. So U average can be said to be proportional to root of T. So just substituting the value here, so U average is proportional to root of T, hence Z1 would be proportional to root of T, and n star is proportional to P by T, hence we can write that Z1 is proportional to P by root T. Okay, and now what about Z11, which is the collision frequency? Z11 is nothing but the collision frequency or the number of collisions when many gas molecules are moving and colliding with each other. So this is simply writing collision frequency. So it would be, rather it is dependent on U average times n star squared. So we can write it like Z11 is proportional to root of T multiplied with P upon T whole squared. So we can write Z11 is proportional to P square upon T to the power 3 by 2. So with this we come to the end of this lecture and the end of this chapter, which was kinetic theory of gases or KTG. In the next lecture or from the next lecture onwards, we'll be taking on another chapter which is real gases. So till then, good luck and goodbye.